Hello everyone, my name is Adlin Charlie and today I'll be explaining to you what latent heat is and also showing no matter what the phase change is, the temperature will remain constant. I'll be also applying the formula E equals ml in order to depict further understanding. What is specific latent heat? Specific latent heat is the amount of heat required to change 1 kilogram of a substance from one physical state to another without any change in temperature. It can also be defined as the heat energy absorbed or given out when a substance undergoes a state change. For example, the heat energy absorbed when a candle burns and the solid wax melts. When talking about specific latent heat, there are two main things to note. Firstly, the specific latent heat is particular to state change. What this means is that the latent heat when changing ice to water is going to vary when changing water to gas vapor. The second main thing to note is that the temperature will remain constant. It will only change once the state change has completed. Now that we know the two main rules of specific latent heat, we're able to apply it into the visuals as shown on the screen. As heat is applied, the ice warms up and moves along the sloping part of the graph while it is still a solid. When the ice starts to melt, the temperature stays constant even though heat is still being added. This flat section on the graph represents the specific latent heat of fusion. The energy supplied is not used to increase temperature, but to overcome the forces between the particles so the solid can change into a liquid. Once all the ice has melted, the liquid water heats up and the temperature increases again, shown by the next rising line on the graph. As the water turns into a gas, the temperature stays constant once more. This flat section represents the specific latent heat of vaporization, where energy is used to separate the particles and change state from liquid to gas. Before we start solving equations, it is important that we can understand the differences between heat of diffusion and vaporization heat. Specific latent heat of fusion is the amount of energy needed to change 1 kilogram of a solid into a liquid at its melting point without any change in temperature. For water, this value is 334,000 joules per gram. Specific latent heat of vaporization is the amount of energy needed to change 1 kilogram of a liquid into a gas at its boiling point, also without any change in temperature. For water, this value is much larger at 2,260,000 joules per kilogram. The main difference is the change of state. Fusion is solid to liquid, while vaporization is liquid to gas. Vaporization requires more energy because the particles move much farther apart. Now it's time to solve the equations using the knowledge gained throughout this video. So, firstly, to calculate the heat energy needed to melt ice, we use the equation E equals m times L. In this equation, E represents the heat energy measured in joules. The letter m stands for the mass of the substance in kilograms. The letter L is the specific latent heat of fusion, which tells us how much energy is needed to melt 1 kilogram of ice without changing its temperature. In this example, the mass of the ice is 4 kilograms, and the specific latent heat of fusion of water is 334,000 joules per kilogram. Now, we substitute these values into the equation. So E equals 4 multiplied by 334,000. When we calculate this, we get 1,336 joules of energy. This large amount of energy is needed even though ice stays at 0 degrees Celsius while melting. The temperature does not increase because the energy is used to break the bonds